Awesome. So I'm Conor Leary. I'm the engineering manager for the data platform team. We're in charge of a couple different APIs and data services for Ava Labs. And today we're going to go through the Glacier API. Also, it is my first time using one of these mics, so if something's going wrong, someone look at me in the crowd and give me a heads up. All right, so to set the stage, we're going to go through what is Glacier, why we built it. We're going to go over a couple feature overviews. It'll mostly be screenshots of different front-end products using the API. And then we have a couple recorded demos for you guys. We'll go through a couple upcoming features, kind of the future of this API, where it's going in the next 3 to 6 months. And then we'll just go to a Q&A. So what is the Glacier API? So Glacier is primarily an index blockchain data API for the Avalanche network. And when I say indexed blockchain data, it means a few things. But at its core, it's really about getting data off the various nodes, whether that's Go Ethereum, whether that's Avalanche Go, that is generally hard to get directly from the node itself. So one good example of this is getting balances for an ERC20 token. You can typically fetch this directly from a node, but you need to know exactly which contract address you want to look up. So you can call into the chain. You can say, hey, here's my address. Here's this ERC20 token that I want to look up the balance for. What is the balance? But if you don't know that contract address, you're kind of out of luck. The Glacier API indexes all of your interactions with smart contracts. So we have a single paginated API that will return every balance that you have across the blockchain network. Well, that's not good. OK. Just quick, turn it off, turn it back on again. All right, so what chains does Glacier API serve data for? So we do all the primary networks, the CP and X, all EVM-compatible blockchains and subnets. I know I should be using the term L1s. It's been a big point of this conference. I'll probably have subnets in here a lot, and I'll probably accidentally say it a bunch. And then we also have the cross-network communication for whether that's atomics for the PC and X or teleporter messages or ICM, whatever the new terminology is on that front. Similarly, Glacier, while primarily an index API, has started to really evolve into an API gateway for other APIs and Avalanche data products. So whether this is directly the RPC nodes that you would use to communicate with the chain, whether this is our webhooks products or TX exporter products, you primarily call in the Glacier to use all of these different data products or API services. Now, Glacier powers the core front end. It powers sort of the Avalanche Explorer, the Teleporter Explorer, all of the validator pages that we offer. Most Ava Labs products that you see on the front end, it's Glacier behind powering it. We use it for a variety of internal products as well. And there's a large number of subnet operators using it to power their services as well. So why did we build Glacier? There are other blockchain indexers. I'd be shocked if you guys didn't know that. There are other blockchain explorers or wallets. But we built Glacier because we wanted an Avalanche-first indexer. A lot of these existing indexers on the ecosystem are built with Ethereum in mind. They're built with the concept of reorgs, with non-instant finality. And we wanted to build something that was centered around Avalanche. Similarly, a lot of the data, especially the P chain and X chain, is really complex. It's really difficult to work with, and it's really hard to parse and figure out what's going on there. So by having an in-house API like this, we're able to work with the platform team directly, whether it's the upgrades, whether it's when Teleporter launched. We work alongside the platform team to know exactly how to parse this data, how to index it, and how to serve it to the community. We've generally followed a build once, use everywhere kind of philosophy. So we've made the API incredibly front-end agnostic, so that anybody can use it. It's used across all the front ends in Ava Labs, externally. We don't really leak implementation details for front ends in this. We just keep everything very generic so that it can be reused. And lastly, one of the biggest reasons we wanted to build Glacier is we wanted to build a lot of L1 specific feature sets. So it turns out L1s have a lot of different feature requirements than a large public network. So for the most part, for large companies, the general thing we've seen is a lot of them like to build private L1s first. They don't want to leak that they're building it. They don't want to let people know that, hey, we're a large corporation. We're putting a bunch of stuff on chain. We're doing some experiments. So they'll usually come to us and say, hey, we want a fully private network. There's obviously some details on the P chain, but all of the indexers or public APIs will put behind authentication so that they can control access. They can also configure who has access to it. So if they want a few of their partners to be able to authenticate, use their RPCs, use their data indexer, they will be able to do that and control who has access to it. Lastly, there are a lot of regulations about where data needs to be stored for blockchain networks. So we do offer the ability for folks to store their data in any specific regions they want. If they want everything isolated in AP North 1, we'll store everything there. If they want things in EU because of their customers and non-data regulations, we'll put everything there. We have full control over where data is stored and being served from. All right, so let's hop into the feature overview. So buckle up. This will just mostly be screenshots of front ends and me talking for the next 5 or 6 minutes. But it should be a good illustration of some of the data that Glacier is serving and some of the potential use cases. So for the next few slides, we're going to walk through kind of the largest data object in the EVM to the smallest. So starting off, we're going to go through, the largest thing in the EVM world is a chain. The next largest is a block. So Glacier here, we have all of the chain information for the various subnets we're indexing. We have a lot of chain information for sort of all of the subnets in general, but for the ones we index, we do have a lot of augmented off-chain data we're kind of pulling in. So we have the created, we have the VM name, the VM ID, we have the RPC, so how you can talk to it, the WebSocket URL. Basically, you can think of it as a metadata lookup for a EVM chain. For blocks, this one's not anything really special. This is going to be mostly your vanilla block information you can get directly from the node. But we want to make sure we have everything in Glacier, so it's a one-stop shop for reading everything you would want from the EVM. So we do have all of the block information. It is a little bit more nicely formatted than you would see in a traditional node. And we do, at least for the front end, link it to a lot of other stuff to make it easier to kind of grok through. Sort of walking a layer below, we have transactions and we have transfers. So transactions are typically the event you submit on chain where you are submitting a transaction to the chain, whether that is native, whether you're talking to a smart contract. We do try to pull in a few off-chain data sources to make this more usable and make this an easier to understand fashion. So a great example of this is the method hash and the method signature here. So when you call a smart contract in EVM, you're basically just passing a hex value, and that is mapped to a function on the smart contract. But there's no like string interpretation. There's no English word for what you're doing. So we do ingest all of the different signatures, all of the hexes to string mappings that we can find, and we do put that right in there so you can understand or you can see at least some text about what is being called. Similarly, if we're able to pull in price data, we pull in price data for the transaction at the time of transaction. So instead of needing to interpret things in terms of tokens and everything like that, you can have a USD value associated with it. On the transfers and sort of the full network view, this is really kind of a little bit more of our methodology and ethos for the Glacier API. We try to pull in as much data as possible. If a wallet address the state of it is being changed in any way, we have one paginated view for you to pull all that data and see whether you are receiving an airdrop, whether you are sending a transaction yourself, whether you are involved in an internal transaction. We will parse that data out if there's a state change to your AN address, and we'll put it in one view for you. And I'll get more into that in a little bit. So then going down to the smallest kind of object site, we have balances and we have NFTs. So for balances, I kind of mentioned a little bit before. We're pulling in every balance that you have in one paginated view, so you don't need to know what tokens to look up balances for. You just need to know an address. The NFTs, we are indexing every NFT on the primary network on C-Chain, on every subnet we're indexing. We're actually pulling and ingesting all of the metadata and caching the images. So generally, if you've worked sort of with NFT data, it's around usually an 8 to 12 second load time to just get that image. You have to go to IPFS, get the image URL, go back to IPFS to get the actual image. We cache all that, so it's usually a sub 1 second load time. Spoilers, I do have a demo with that in here towards the end, but that's at least why we're doing it. Moving a little bit away from EVM, we do have a sort of set of endpoints around Teleporter or ICM. There's a lot of interesting use cases for Teleporter, and I think indexing it is very difficult because you need to index both networks involved in a message. Because the messages are emitted on chain, if you want to know what happens on chain as a result of the message, you need to know the recipient chain, and you also want to know information about the sender chain. I see Michael over there looking at me. I'm probably getting the terminology wrong, but that's okay. I think everyone here roughly understands. So right up here, we have two examples of different Teleporter messages, one of which where we don't actually index the destination. We put as much data as we have. We go into the message. It's kind of very, very bland. You know what is roughly being sent, but you're not really knowing much about what's happening on the destination. If we go into an actual message where we index both sides, both the sender and the recipient chain, we have the full message details. We have the exact data, the arbitrary data that was sent over as a result of the transaction. We know exactly what state it is in, kind of where it is in its life cycle. We have the hash from the sender. We have the hash from the recipient. And we basically have everything you would need to then go and action that message in an off-chain fashion. And lastly, just to give a little bit more of the breadth of what is in Glacier, we do index every single validator node across the network. We are measuring all their historical rewards, their current rewards, the delegations to them, what the projected rewards are based on delegations, the historical uptime performance, anything you would want to know about a specific validator or an L1 and the validator set isn't, the validator set that it contains, you'll be able to kind of go to Glacier, you'll be able to pull this data right from it and get a full historical view of exactly what's going on chain. It's great if you're deciding what to delegate, if you want to go see the historical performance and make sure, like, hey, has this node gone down repeatedly in the past? All right, and now we're to the video performance. I've seen about 5 live demos this week. 4 of them didn't work, so I've recorded all of my demos. I did do a dry rehearsal of this morning, and one of my videos didn't work, so let's hope that doesn't happen. All right, so in this demo, we're going to show what exactly happens in the Glacier API when you interact with a contract for the first time. So I'll try to narrate what is going on as we are going through. So over here we have the core wallet. We'll pull up our balances. We'll see we don't really have anything. We have just two tokens in there. We are actually going to do a swap for USDC, and then core, which is calling our endpoint, will live populate USDC. Core doesn't need to know that you've interacted with it. You don't need to do any impact. But because you performed an action on-chain with a new token, this balance will then be populated through the Glacier API. So it's a really slick experience for wallets or anyone kind of building portfolio views to not need to worry about every token that a user has interacted with, just to go one place for it. As you can imagine, this has been taken advantage of in the past by people airdropping spam tokens or scam. We do have an optional parameter in that endpoint to filter out spam tokens, whether through a configured list of tokens that we manage on the core side or through sort of naming conventions. If you see a URL in the name, usually it's a spam token. So we do have the ability to filter that out for wallets as well. We have a very similar example here of an ERC 721. We are going to mint it. Yep. We are going to mint a new ERC 721 on chain here, and we're going to see how fast that data is loaded in the core through the Glacier endpoint. both the image and the fact that this address now has a new set of ERC 721s. All right, so we've minted the NFTs. We're going to go back up. And there we go. We have the images. We have the fact that they own this NFT. It's all there. The end implementer calling the API doesn't need to worry about any of it, doesn't need to worry about what's happening on chain. Just call a single endpoint to get all of this information. And then lastly, second to last, we have a quick demo around sort of the breadth and the amount of data we're pulling in for Glacier for an EVM transaction history. Whether right now we are going to perform a series of actions, we're going to go get some Wavox, we're going to go buy an NFT, and then at the end we're going to kind of show the view that you get from it. You'll see every single action that is being performed in this demo, from the swap to receiving the NFT. We're calling a contract for Trader Joe's, so we're actually performing some internal transactions here where we're going to be calling in to buy an NFT. We're going to call a smart contract, which will call some other subsequent smart contracts. So in the Glacier API, we're parsing through all of those internals. We're kind of teasing out exactly what state update has happened, and we're displaying it in one nice, easy-to-use fashion for everyone to see. There you can see you have all of the actions that were performed on chain that updated the state of your address, all in one format, all in a nice paginated list. And lastly, this is a little bit of a bonus feature. Most of the work is happening outside of the API, of the Glacier API, but it is you do create all of these webhooks through it. The data platform team has been working really hard on this new product here, so I promise I'd demo it, even though it doesn't quite fit in with the rest of the presentation. So basically, this is a real-time data streaming solution. If you want to basically have a way to action very specific information on chain, sort of events to a specific address, a smart contract performing an action, we've built a nice portal for you to create webhooks, which will basically ping your backend server whenever an event matching this criteria happens. So there are two demos in this. We're basically doing a traditional wallet, and then we are doing a smart contract at the second part of it. So we've created the webhook, and now we're going to send a quick transaction from one address to another. We are using MetaMask as our second wallet. Please don't tell Akash. It was just easier to have two wallets in the extension and send one funds to another. All right, unfortunately, webhooks is a little bit too fast for us to see the transaction loading. It's happening almost instantaneous as the transaction is executed on chain. This next example, you'll be able to see that a little bit more. So we're putting in the contract address for USDC. So anytime someone sends USDC on chain, this webhook will get fired. USD is a good example just because there's tons of activity. You'll be able to see this happening in real time. You'll be able to see a lot of these webhook events coming in. But there are a lot more use cases. This is essentially fundamentally how all sniper bots work. They'll monitor liquidity pools on something like Trader Joe's or Uniswap. They'll see as new liquidity pools come online, and they'll immediately buy. Similarly, there are a lot of interesting teleporter applications you could build with this where you monitor the teleporter smart contract address for certain events. You see the events that you care about, and then you can action them off-chain as soon as they're happening. So here you go. You can see all of the events coming in real time. And do whatever you want with them. So let's talk about upcoming features. So this is sort of a rough representation of where Glacier is today. There are a lot more features in there, particularly around the P-chain and X-chain and a couple other miscellaneous data sources. I would encourage everyone to go to the documentation here or the Avalanche Academy to kind of check out more. But kind of talking about where we're going to be in the next 3 to 6 months, we're sort of moving more towards that sort of API gateway layer that I mentioned in the beginning. We are starting to roll more and more APIs behind Glacier so that you have a single point of authentication, a single point of rate limiting and access controls. You have your RPCs in there, which a lot of L1s are using. We're rolling in a couple more APIs in there as well. We are putting dedicated node support behind Glacier, so if you want your own node for sort of any of your indexing purposes or sort of to have sort of a private node, we are putting it behind Glacier, so you'll be able to configure through the Ava Cloud portal. You'll be able to spin up, control who's allowed to talk to or read from that node. We're doing a lot more teleporter support in there, so we have a new teleporter-specific API coming out fairly soon that we'll sort of be announcing on Twitter in the next few days. We are also turning this into a little bit more of a mature API platform. Glacier is no longer in beta. It's sort of fully out. Webhooks is a beta product. But with that, we are putting out some API usage dashboards, so you'll be able to see exactly how you're using the API, what calls you're making, what calls other people are making to your L1 so that you can kind of see like how are people using this, how are people using our APIs. And like every other project here at Summit, we are getting ready for HyperSDK. We are working very closely with that team on an indexer and API solution. So hopefully we'll have that out in the near future and rolled into Glacier API as well. All right, and I got 2 minutes to spare. So even with the technical issue, we got Q&A if anyone has any questions.
Hi, thank you for the presentation. I have one feature request and one question. Feature request is on the list blockchain endpoint. We need a P-chain address, the owner of the subnet as P-chain address, which doesn't exist there in that endpoint. We had to do 2 queries for that, for example.
Okay, yeah, we can
nice
definitely
addition,
get that. Yeah, that seems like a pretty reasonable request.
The question is, I'm a validator since Genesis, and I have so many validation history. And in the core wallet, I have a huge problem because of that. Somehow, my browsers, the browser actually throws error. Like, for me, it says, okay, stop script, etc. That level. I think it's because of the history of the validation, maybe, or maybe something else. But I think now I understand it's related to Glacier APIs somehow. So maybe you can address that.
Yeah, so I would recommend going directly to the Glacier API, especially if you're doing a larger balance. Usually the front end displays kind of trying to load and paginate all that data will have some issues. There's also another feature which is in Glacier. It does have a front end and core called the transaction exporter. We built this for particularly people with huge address histories that want to sort of get a full record. So it's essentially just a CSV exporter for all of your history. You can pass in a node ID, you can pass in addresses, and it'll just give you a nice CSV, particularly if you're in tax season and you need to file all of that.
Other question?